This is Module 2, Lesson 5, Part 3, and we're going to take a look at the examples that are related to finding the cutoff score. So it's type 2 questions. So these questions will have say something like find the cutoff score, find the value corresponding to a certain percentage, and the calculator command that we referenced earlier is the inverse norm. You have to give it 3 parameters or 3 pieces of information: the area to the left of the cutoff, the mean, and the standard deviation. Guys, it is so important that you use the area to the left of the cutoff. That's how the calculator is programmed, so if you give it the wrong information, obviously you're going to get the wrong answer. Also, that area, which is typically given as a percentage, should be converted to a decimal before entering it into the calculator command. So let's revisit an example that we've been looking at already today. According to the ACT, American College Test Math, results from the 2017 ACT testing found that the students had a mean math score of 20.7 with a standard deviation of 2.0, and assume the distribution is normally distributed. So first off, again, remember here that they've identified for us that it is normally distributed. They have given us the mean score, and they have told us the standard deviation. Remember, those are the 3 things you have to know in order to work through these type problems. Also, remember that that same information could be presented in symbol form, and so you would have X is approximately normal with a mean of 20.7 and a standard deviation of 2.0. Okay, it's just the shorthand notation. Notice how the question is worded here. It says find the 75th percentile. Okay, so they're asking me about a percentile, or in other words, what is the cutoff score that corresponds to the 75th percentile. Okay, so it's a little bit different, but that idea that they're asking me for that cutoff score is my clue that I need to use the inverse norm command. We still want to draw a picture and kind of get a sense of what's going on here. So I'm going to draw my horizontal axis, my bell-shaped distribution. The mean is in the middle, which is 20.7. Now, a couple things you may want to remember is that the mean automatically divides your data set so that you have 50% below the mean and 50% above the mean. We're interested, if you want to think about it, if you start on the left of the distribution, it's like this distribution runs from the left, you're way over here at like 0%, and all the way to the right, you would be at 100%. So you got to think about it. The mean's in the middle, and we're looking for the 75th percentile. Remember, by definition, that means that 75% of the data are below a particular score, which is what we're looking for. So the 75th percentile is probably going to be somewhere along in here. Okay? And I'm trying to figure out what score that would be. This would be the 75th percentile cutoff. Okay, now again, by definition, that means that 75% of the data are below or to the left of that score. So see, in this case, we actually have been given the information about the region or the area on the left. Okay, so I'm really ready at this point to enter the information. My command would be inverse norm 75% as a decimal is 0.75. Mean is 20.7. Standard deviation is 2. Okay, I'll pull my calculator up. Second vars, which is next to the clear button, you get your distribution menu. Now we're using inverse norm, which is option 3. My area to the left of the cutoff is 75% or 0.75. My mean is 20.7, and my standard deviation is 2. And I hit enter. And so it tells me that basically if a student scores 22 on the ACT, then they would be in the 75th percentile. So if I scored 22 on the ACT math, then it would indicate on my score report that I was in the 75th percentile. That means 75% of everybody who took the test scored below 22. All right, let's look at another example. Men's heights are normally distributed. So here again, they tell us it's normally distributed with a mean of 69 inches. So they tell us the mean, and the standard deviation of 2.8 inches. So I have everything I need to work the problem because I know it's normally distributed, I know the mean, and I know the standard deviation. The standard casket has an inside length of 78 inches. A manufacturer of caskets wants to reduce production costs by making them smaller. What inside length would fit all men except the tallest 1%? Okay, again, kind of the clue is really asking me, what is the cutoff score? What length caskets could we make if we exclude the tallest 1%? Okay, so let's see if we can get an idea of what's going on here picture-wise. Okay, so I have my horizontal axis, my bell-shaped curve. The mean is in the middle, which is 69 inches. And we're going to make caskets that fit everybody except the tallest 1%. Now here again, you may have to think a little bit about where would that tallest 10% be? Remember, this would go from the shortest person to the tallest person. We always go small to large. So if I'm cutting off the top 1%, that's going to be somewhere along in this area, and I'm looking for that cutoff score. So this region here to the right would represent the tallest 1%. Now, guys, be careful, though, because remember the command wants to know the area to the left. So I actually need this region, okay, because I need area to the left. Well, if the total area under the curve is 100%, which we talked about earlier, 100% minus the 1% we're going to exclude leaves 99% that would be included or be able to fit in the caskets. Okay, so you're really going to use the 99% in your calculations because you need the area to the left. So our command would be inverse norm 0.99, convert that to a decimal, 99%, mean of 69, and a standard deviation of 2.8. So I'm going to pull the calculator up. Let's walk through it. Second, bars. Inverse norm is option 3. Area to the left is the 0.99 or 99%. Mean is 69 inches, and the standard deviation is 2.8 inches. Enter. So in terms of our cutoff score, the cutoff score is going to be about 75.5. So our cutoff score is 75.5 inches. So the casket maker could shorten his caskets by roughly 2.5 inches. Okay, so he would be able to save money probably over the long haul. Okay, I want to kind of see if I can set up the second one, this last one for you. I don't know if I'll have time to finish it for you. Okay, we got a citrus farmer. They tell us it is a normal distribution. They tell us that the mean diameter of the mandarin oranges is 5.85 centimeters, and the standard deviation is 0.24 centimeters. This one's a little bit different because it's asking you about the middle 30%. Okay, so I want to try to sketch you a picture of what's going on here because that's where it gets a little tricky. Okay, so if you'll draw yourself a picture, it'll help. Okay, so you still have your normal distribution, your bell-shaped curve. The mean is in the middle, which we know to be 5.85 centimeters. Again, remember, this distribution runs from 0 to 100%. But you want to know what's in the middle, okay? So you're looking for what's in the middle. So remember that this is a symmetric distribution. So if I want 30% in the middle, that means I'm going to have 15% between the mean and this cutoff. Okay, so here's cutoff 1. Right here. And there's 15% between that cutoff and the mean. And if I go 15% between the mean and go up towards the higher one, I'm going to find the other cutoff score. So this would be cutoff 2. So I really have 2 cutoff values here. But guys, you got to be careful either way because you got to figure out what's in these other regions. Remember, it's a total of 100%. The mean divides it 50-50. So what you're going to have then is in this little tail out here, you're going to have 50% minus the 15% or 35%. And so since it's a mirror image, that also tells me that here on the other side, I'm going to have 35%. So you got to be careful about what values you enter into the calculator. Okay, so why don't you see if you can figure that one out, and I will post the answers for you.